Hello everyone. Now we have a question which says that the number of geometrical isomers of the complex RhH C triple bond Cr2 PMe3 whole thrice. So this is our complex and we are being asked to identify the number of geometrical isomers for this complex. Okay, so if we see this complex carefully, so I am writing it again, CR whole twice and then PMe3 whole thrice. Okay, so if we look at it carefully, then we will see that we have 1, 2 and 3. 2 plus 3, 5 and 1, 6 ligands. Okay, that means this complex is an octahedral complex. Okay, so this is an octahedral complex. And if you have some idea about geometrical isomerism in coordination complexes, then you can identify this complex as M A3 B2 C. That means we have three distinct type of monodentate ligands. Okay, and there are 3 of the type A, 2 of the type B and 1 C. Now in this situation, what we can do first, our first step will be to identify the ligand combinations that is possible for this complex. Then only we can identify the number of isomers that it can form. And for this complex, the possible ligand combinations, if I start alphabetically, then MAA, then AB, and then BC. So this is one possibility. So we have 1, 2, 3A, 2B and 1C. So MAA together, then AB and then BC. So this is one possibility. Then again, do we have any other possibility with AA? Yes, we have. So MAA. And if we interchange these positions, then we have A now with C and then we have B and B. This is the second possibility. So MAA, AC, BB. Here also we can see 3A ligands, 1C ligand and 2B ligand. So this is one. So this is the second possible ligand combination. And then we have AB, okay, and then again AB. So AB, AB, and then AC. So this is the third possible ligand combination. Okay, so here also you can see there are 3 A's, 2 B's and 1 C. Now apart from this, if you try, then you will get all the redundant combinations. That means all the combinations will be repetitive. Either you will get any of these 3 combinations which are repeating. If you try again with other combinations of AC, AB, BB, BC, AB. So whatever you try, you will get the repetitive combinations from any of these 3 ligand combinations. So basically we have only 3 types of combinations that is possible for MA3B2C. So a total number of geometrical isomers will be 3 from here. And now before we decide or before we write an answer, let us try to draw the structure of these geometrical isomers for more clarity. Okay, so now we have our 3 possible ligand combinations and the 3 geometrical isomers corresponding to these combinations. Now we try to draw the structure. Okay, so basically we draw a dashed wedge on both the sides and a solid wedge on both the sides, left and right hand side, and then we draw a line which is one on top and other at the bottom for the octahedral complexes. Then we will arrange these ligands against each other. So we have MAA. So let us arrange AA here. Okay. And then we have AB. Okay. So we can arrange AB here like this, AB. And then we have BC. Okay, so B and C against each other. So AA is trans to each other, AB trans to each other, and BC trans to each other. Like this we have to arrange. Now we do the same for the second isomer as well. So I hope you understand the meaning of the solid wedge and dashed wedges. So solid wedge gives an idea that the particular group is facing the observer or it is above the plane, while the dashed wedge gives an idea that the particular group or the ligand is behind the plane or away from the observer. And these two vertical lines, these are in the plane of the paper. Okay, and what we have to do, we have to arrange these against each other each time. So again we have AA, so we can place the AA here like this. And then we have AC, so A and C trans to each other. And then we have BB, again BB trans to each other. Okay, now in the third one also we have AB. So AB, we put one at the top, other at the bottom, trans to each other. Then again we have AB. So we can put A and B like this, trans to each other. And then we have A and C like this. Okay, so this is the orientation of the ligands. Now you can consider, let's go back to the question again to check on these groups. So we have 3 PMe3. So we have trimethylphosphine 3 ligands. So 3 PMe3 we have. So we can imagine that these A, we have Ma3, no, we have written here Ma3B2. So A3 belongs to PMe3. Okay. B2, the two ligands are C triple bond Cr2. So this C triple bond Cr, the two ligands, these are the three ligands, and one single ligand is the hydrogen H over here. Okay, so H. So this we can imagine for the given groups. Now it will be easier for us if we base our structure based on these A, B and C. We have understood what is A, what is B and what is C according to this question. But if we make something like this, then it will be easier to understand. And later on, you can make whatever ligands you want to put. So now, in this question particularly, it has been asked the number of geometrical isomers. But if in that very same question, if someone asks that, is there a possibility of any optical isomer or is there any chirality in this molecule? Then also, we should be prepared to answer this question. So what we do, we have to check the chirality. Let us check the chirality of these three isomers in this same question. Now, if we put a mirror plane here, okay, so you can imagine if we put a mirror plane, then we get a reflection of AA, same ligands, okay, and then also the reflection of these two, BB, if we put a mirror plane somewhere here also in the vertical axis. If we place it somewhere in the vertical axis, then also we get the BB reflection, and in the horizontal axis also we get the reflection of the AA ligands. That is why it has a plane of symmetry, and that is why this molecule is achiral. And now for the second isomer. For the second isomer also we apply the mirror plane here, and then we can get the same reflection of AA ligands, okay, for this second isomer as well. So this is also achiral. Now for the third isomer, what we can do is placing the mirror plane on the diagonal axis. So placing the mirror plane on the diagonal axis will give the same reflection AB on both the sides. So this molecule is also achiral because this has a plane of symmetry. So all the three isomers have a plane of symmetry and all the three are achiral. That means there are no optically active isomers. And that is why this complex will show only 3 geometrical isomers. And to get into a few more details, if you remember geometrical isomerism, you can see here that A and A, these are lying on the triangular face of this octahedral. That means something like this. Okay, so if I make it like this, so this is lying in the triangular face. So 3 A's, 3 identical ligands on the same side, that is on the triangular face of the octahedron. So that gives rise to the facial, cis-facial isomer. If you remember, facial and meridional isomers also exist for PMe3 type of complexes. So we have one A3 here. So this A3 lying on the same side gives rise to facial isomers, which is cis. And similarly, we have this one. Okay, so two isomers A and A. Okay, A and A together, and then they are intercepted by another isomer B, and this is again a triangular face, and this kind of arrangement is known as the cis-meridional. Okay, cis-meridional. And this part, the second isomer where the ligands are trans to each other, AA is trans to each other, BB is trans to each other, and this is the isomer which is the trans isomer. Okay, so cis trans isomer exists for geometrical isomerism, and we can identify the cis meridional and cis facial isomers and the trans isomer in these 3 geometrical isomers of the complex of the type PMe3B2C. So in total, we have how many geometrical isomers? We have 3 geometrical isomers. So 3 will be the correct answer for this question. So I hope you understood the explanation that how we have to first make the ligand combinations possible, and then we arrange these ligands trans to each other for each of these ligand combinations, and then we can identify whether the molecule is chiral or achiral, imagining the mirror plane and the reflection, and whether there is a possibility of any optically active isomers or not. So I hope this explanation was clear to you. If my videos are helpful to you, please like, share and subscribe, and please let me know in the comment section what you want to learn next in chemistry. Thank you so much.